Hey P-Calculus, this is Mr. Szybisty, and today we're going to talk about implicit differentiation. One of the times we'd have to use this is there are many times when a function or a relation like this, we can't solve for y. We can't get the y all by itself. When this happens, we need to use some other techniques, and that's why we have this implicit differentiation, which will give us the rules that allow us to take a derivative with this, even though we can't get a y by itself and get it to be a y equals. So first we need to know a couple rules about implicit differentiation before we move on. Our first rule says when you take a derivative of y, you're going to multiply that derivative by dy dx. And this is because of the chain rule. So if you have something like y cubed, the derivative of it is going to be 3y squared, and then we'll use this chain rule to multiply it by dy dx. If you take the derivative of an x, we just do it like we usually do. There's no chain rule because the x is sort of all by itself. And then finally we have to follow all other rules like normal. Rules like the chain rule, product rule, and quotient rule. So here's our first example. Start with the first term. The derivative of x squared would be 2x plus the derivative of 3y squared would be 6y. And because I just took the derivative of a y, I'm going to add the chain rule dy dx. This then equals 30y squared dy dx. Now our issue is you're going to have terms that have a dy dx attached, like these two. But you're also going to have terms like this 2x that will not have a dy dx. Here's what we want to do. In order to find the derivative, we are going to get all of the dy dx's to one side of the equal sign, all of the terms without a dy dx on the other side. In order to do that, I'm going to subtract 6y dy dx from both sides of the equation. So I have 2x equals to 30y squared dy dx minus 6y dy dx. Now in this part right here, you'll notice that there is a common dy dx. And what we'll end up doing is we are going to pull that to the outside. Our final thing is we're going to divide both sides by this part right here, 30y squared minus 6y. We'll divide both sides by it to get the dy dx all by itself. So you'll have 2x over 30y squared minus 6y, and that's our derivative. And if you want, you could simplify this right here. Since every one of these terms has a factor of 2, you could divide out that GCF. But for right now, we are going to write this as our answer. There's your derivative based on implicit differentiation. And that's one of the interesting things about implicit differentiation is that your derivative, your dy dx, will probably have x's and y's in it. And that's because your original could not be written just in terms of y. Let's take a look at example 2. In this, we take the derivative term by term. The derivative of x squared is 2x. The derivative of y squared is 2y. And remember, we have to add dy dx because we took the derivative of a y. And that equals xy. This x times y means I'm going to have to use the product rule. So it's going to be the derivative of the first. Derivative of x is 1 times the second plus the derivative of the second. The derivative of y is 1 dy dx. Remember, you took the derivative of a y times the first, times x. So what I end up with right now is 2x plus 2y dy dx is equal to y plus x dy dx. Now I have to get all the dy dx's to one side and all of the constants to the other. So we'll have 2x minus y because I subtracted this y over to the other side, and that is equal to x dy dx minus 2y dy dx. The left side's the same, and this will be equal to x minus 2y dy dx. And the reason, remember, we get the dx's on the same side of the equation is so that we can pull them out and have it as a factor. So now I can divide both sides by x minus 2y, and our final derivative, dy dx, will be 2x minus y over x minus 2y. That's our derivative. No further simplification is possible. Now let's move on to a u-try. Alright, so here we have a u-try. You guys try this on your own. Notice with this first term, you're going to have a sign of y, which means you'll have a chain rule dy dx at the end. Cosine x won't have anything, And the 3 is just a constant, so remember the derivative of that is going to be a 0. Get the dy dx all by itself and see if you can get the right answer. The answer you should have gotten was dy dx is equal to sine x over cosine y. Work back through the problem again if you didn't get it, and make sure you write down any questions that you have so we can answer them tomorrow in class about what the correct answer is. Now let's move on and talk about some more of the rules in depth when it relates to implicit differentiation. The first one talks about the product rule. Now, we've seen a product rule before, but the way that I would handle this one right here is I would pull the 3 to the outside, and then I would worry about the xy. So I know I'll worry about the 3 at the end and multiply it. The product rule says take the derivative of the first, the derivative of x is 1, times the second, plus, keep the first, and then the derivative of the second. The derivative of y is 1 dy dx. So our product rule would be this, y plus x dy dx. I highly recommend, because the product rule comes up so often in implicit differentiation, that I would memorize this, that the derivative of xy is y plus x dy dx. That way you don't make a mistake, and it allows you to work a little bit quicker on a quiz, a test, or an exam. So make sure you have this in your back pocket, you have it memorized, and you'll be all set. Now let's take a look at quotient rule. Quotient rule is going to follow the same rules as before. Remember, it is low d high minus high d low over low squared. Quotient rule begins and ends with the denominator. So our quotient rule for implicit differentiation is low times the derivative of the high minus the high times the derivative of the low. The derivative of y would be 1 dy dx divided by low squared. So y minus x dy dx over the denominator squared. Now let's look at chain rule. Here we're working with the chain rule, and notice that there's an inside function. The x plus y has been composed here, so you have secant as the outside function, and then you have this inside function. So we'll need the chain rule. The derivative of secant is secant tangent. Keep the inside function in there, and now we will multiply by the derivative of the inside. The derivative of x is 1. The derivative of y is dy dx. And so that's how we use the product rule, the quotient rule, and the chain rule as it relates to implicit differentiation. Let's do a couple more examples, and then we'll be ready for more practice. So when I'm taking the derivative of this, I've got tangent xy plus 3y squared is equal to 5. And so I start taking term by term derivatives. The derivative of tangent is secant squared, keep the inside function, times the derivative of the inside. The derivative of xy, remember that's our product rule, is y plus x dy dx, plus the derivative of 3y squared is 6y, and we took a derivative of a y, so we add in the dy dx, and that's equal to 0 because the derivative of 5 is 0. Now I have to get the dy dx's all by themselves. I need to get them over to the other side of the equation. But it's being multiplied by the secant squared xy. So what I'm going to do is I'm going to distribute secant squared to both of these terms so that I have no more of the multiplication across. So I'll have y times secant squared xy plus x secant squared xy dy dx plus 6y dy dx equals 0. And now I can subtract the two terms that have a dy dx over to the other side and factor it out. So we have y secant squared xy equals negative x secant squared xy minus 6y, and there's the dy dx. Notice I already moved them over, which means I had to subtract them, and then I pulled the dy dx to the outside already. So I kind of did two steps in one there. Last thing I need to do is just do the division, and I'll have my derivative, y secant squared xy over negative x secant squared xy minus 6y, and that is my derivative. So this was an example where we had to use a product rule in the middle, And one of the toughest things is getting the dy dx's to the other side of the equation. Now it's time for our last U try. Alright, AP Calc, here's your last implicit differentiation U try. Y cubed plus cosine xy is equal to y squared. Give this one a shot, take the derivative, get the dy dx all by itself, pause the video, and let's see if we can't get the right answer. And here's the derivative you should have gotten. Dy dx is equal to all of this. So remember to make sure you write your summary, write down the questions that you've got. We're going to come into class, we'll talk about it. A friendly reminder of one of the best ways to study is to go back and watch this video after you've done the practice. I think a lot of things in the video will make a lot more sense once you've talked to other people and have figured a few things out. I'll see you guys in class. We'll talk more about implicit differentiation.